In this session we're going to talk about lessons learned from UK decarbonisation trials in road, rail, maritime and aviation. And I'm welcomed here with Michael Hurwitz, who's a partner at PA Consulting, and he's representing the roads perspective. We've got Jim Brewin, Chief Director from Hitachi Rail UK. Surprise, surprise, it's looking at the rail perspective. Jane Thompson, Aviation Director at ICF and Deputy Chair of the British Aviation Group. And Kirsty Gouck, have I got that right? Oh, close. Systems Engineer from Connected Places Catapult, who's here looking at the maritime and ports perspective. I'll just do some opening remarks setting the scene, and then I'm going to hand over to our panelists to do a short presentation, and then at the end I'm going to do some Q&A, so if you've got any questions, then save them for the end and we'll put your hand up and I'll come to you. So for those of you who weren't at the last session, we had a great session on energy and how energy and transportation are, in essence, two parts of the same coin. You can't have decarbonised transport without energy. You can't have, and so how do we look at that? And actually, in the last session, we talked about the government data for 2023 shows that actually transport is the biggest contributor to greenhouse gases, and whether from number one being cars and taxis, aviation, HGVs, light vans. So how do we come together to, and Interchange is great at that, how do we come together to sort of share best practice, share learnings, and cross-pollinate between the silos that currently exist in how we operate in maritime, roads, rail and aviation. And so today's all about some cross-sharing that knowledge. It's something I feel passionately about, helping to drive that collaboration, and how do we fail fast on new technologies, how do we work together to help UK PLC. So without further ado, I'm going to hand over to our experts and start with Michael.
Hello, everyone. Oh, crap, Andy didn't introduce me. I've got to say it myself. Why am I here? I'm a partner at PA, but I guess before that, I started out in the private sector, went into government, cut a long story short, ended up being the most senior government person, set up OZEV, ran OZEV, biofuels, then went to TfL, things like planning the buses, public infrastructure for EVs. Then I was in an EV startup for commercial vehicles, and now I run part of PA, which is all about the future of energy. So everything from investors, the banks, the fleets, the technology companies, and the infrastructure companies that make this stuff happen. That's why I'm talking about roads. Okay, I'm going to talk about two key areas in the next few minutes. It's about trials. It's the interesting stuff, and I'm going to talk about big vehicles and big systems, because I think there's some very clear messages that are coming out from them. Why big vehicles? Well, Bob kind of mentioned it earlier. We're kind of doing okay on cars. You know, electrification is big. When I was in government, winding back, 2009, we ran what was then the largest ever globally demonstration of electric vehicles in the real world. 2009, it had 349 vehicles. Now, last year, just in the UK alone, 680,000 vehicles were sold with a plug. China, you know, where's this going? 3 to 5 years ahead of the West. Last year, 48% of all new cars had a plug. And it's not happening everywhere, by the way. You know, BYD, by the way, produced 4.3 million new energy vehicles last year. But it's not the same on all vehicles. It's tougher with vans. 7.6% of sales in the UK last year were electric of vans. Trucks, much worse. 0.5% of trucks that were sold in the UK were electric. So we need to focus on those areas. And if it's not electric, is it hydrogen? Well, Andy was saying he's got a hydrogen car. That's pretty brave. A company called Hydrogen Insight actually tracked the number of hydrogen vehicles sold globally. Last year, 12,866. Very specific. BYD, sell every day 11,700 electric vehicles. So, there's clearly certain things are moving quicker than others, but the story on hydrogen isn't over, and I'm going to talk a little bit about that. Okay, so the bigger the vehicle, the harder it gets. Let's talk about what we're learning from trials. Wind back, one of the first studies I ever commissioned in the central government was with Ricardo, asking the exam question, how heavy would a battery need to be to power a 40-ton HGV to give the same range as a diesel? The answer, then, 40 tons, right? That's not a great calculation, but what's happened since then is quite remarkable. Battery prices down more than 90%, more than $1,000 a kilowatt hour at cell level, 70 or less now. Energy density has more than doubled. Degradation per cycle has more than halved. And so actually in reality, and this is honestly, one thing it's taught us, electric is doing far more than I ever envisaged would be, frankly, possible. And so what you're seeing now, Scania, Mercedes, DAF, Volvo, Renault, all have commercially available HGVs. They all top out on a range of about 500 to 600 kilometers, so not full. But back to that weight, those batteries now, for the 600 kilometer range, is 3 tons. Okay, you'd need to double or triple that to have the full range of an ICE, but it's massive. And it's not just stopping there. I don't know if people have heard of Fortescue, the iron ore mining organisation. They're working with Fortescue Zero and Liebherr. You know the mega trucks? You see those things for mining, people standing in the wheels. They weigh 240 tons. They've just ordered 360 electric of those. They have 3.2 megawatt hour batteries. Enormous. But the fact is, more and more applications are becoming possible. So actually, later this week, the formal government programme called ZHID, which is the main demonstrator, trying to trial trucks on the roads in the UK with zero carbon, there's a formal update on Thursday, but I spoke yesterday to Sam Clarke from GridServe, who's running one called Freightway, and he told me actually 3 things, sneaky peek, that these trials are showing us right now. 3 issues still remain. Number 1 is commercial, right? Some freight operators are using these technologies now, but not all. Amazon were doing some, United Utilities were doing some, but not all. So the commercial case is not made. The vehicles are still too expensive, and they are limited to relatively small stem routes. The routes, it's got to be on the right on the right duty cycle. Next one is that technology. The power required is enormous. They're not going anywhere without the power. If you have a line, for example, of 10, 15 megawatt hour chargers, that requires the same energy as a small village or a small town. This is huge amounts of energy. And there's a huge structural issue in the UK about getting those grid and the grid connections. And the final thing is just a day-to-day experience, and I quote, big trucks smash everything up. It's actually really, really hard to think about, bays, the width of bays. These are big vehicles with quite fragile, in some instances, infrastructure, and all of that needs to be worked through. What I would say, by the way, is that the other thing is that let's move beyond electric. I don't think hydrogen is dead. In particular, for off-road machinery, non-road mobile machinery, NRMM, I'm sure many of you know that, is that this is particularly difficult. It's the hardest. These vehicles are probably on site with no fuel supply. They've got to be regularly refueled. Workhorses, constantly working. Very hard if you don't have electricity supply there. A lot of trials right now, so JCB actually putting things in to service. Cummins, a project called Brunel, funded through the APC. Volvo, a European project called Corum. They are now finding that hydrogen combustion is seeming to be a good zero-emission option. One of the nervousnesses for UK government about hydrogen combustion is that it still produces NOx. But the current the current trials are showing that actually in real world, those NOx requirements are well below regulated standards, so better, significantly better than diesel. Okay, those are some of the learning from trucks, but I wanted to leave you with another view. There's a lot of trials right now about not just looking at this as a transport system, it's looking about how transport can actually help the energy system overall decarbonise. To talk very briefly about infrastructure, the UK total grid capacity right now, installed capacity is 116 megawatts in 23. To go electric, NESO, that's the National Energy System Operator, thank you. They look at the projections for capacity going forwards. It's going to have to more than double by 2035, somewhere between 260, 280. By 2050, it's going to have to be almost at 400. They now assume that of that system, you're going to need much more storage to work when renewable energy has intermittency, when the wind doesn't blow and the sun doesn't shine. So just to give one factor here, this is already in their planning. By 2035, they're assuming that the system will need about 38 gigawatt hours of storage, of which they already assume that 10 gigawatts could come from transport. Greg Jackson from Octopus, through flex management, he already assesses that through their 200 and odd thousand of electric vehicles right now, they can already provide about a gigawatt of flexible energy. So there's an opportunity here for turning the transport system not to be part of the problem, but to be part of the solution. And the trials on that, I encourage you to look at a website called V2G Hub. There's 151 active trials right now about can you do smart things to save money, potentially to generate revenue from choosing carefully when you charge, to be smart about that, and potentially even putting energy back into the grid. And there, the benefits are significant. Potentially up to £1,000 per year for a small vehicle. And if you're in a depot where you have predictable cycles of energy use, big batteries underutilized at night, active trials right now are showing savings per vehicle of between £6,000 and £10,000 a year. The US EPA trials of buses, $6,000 a year. Fraunhofer Institute looking at up to 10,000 if it's connected right, doing arbitrage, sending energy back to the grid when it's most expensive. But it's really tough because it means that systems that work together, that need to work together, have never worked together before. Energy, planning, questions about where does the capital outlay reside. But I wanted to leave you with a positive quote. I was told to finish positive. A lady called Dana Meadows wrote a book called The Limits to Growth in 1972, big on systems thinking. And she said this: there's no such thing as separate systems. The world is a continuum. Where we draw the boundary around a system depends on the purpose of a discussion. And what I would say is that the good thing that we're all here is that I think we should try and make it work, because the benefits to energy, the benefits to air quality, the benefits to carbon, potentially the commercial opportunities are huge. And I think it's down to us, and it's a function of a conference like Interchange, to say, well, do you know what? I've had enough of the old boundaries of the system. Let's build some new ones. Thank you very much.
Thanks, Michael, and some great lessons there that we can take away, especially 48% of new cars in China have got a plug on it, so that's what can we learn there. And personally, with a hydrogen car, I'm glad to see that hydrogen is not dead, so that's great news. So next up, we've got Jim, who's going to come and talk about a rail, from a rail perspective. Jim.
Good afternoon, everybody. So I'm Jim Brewin, Chief Director for Hitachi Rail in the UK. My story will come out as we start speaking, but what we're doing at the moment within Hitachi Rail, we took on a very specific objective and a specific task. I was interested to hear Michael say the larger it gets, the harder it is. we went straight for that. We went for scale and we went for long distance, specifically around intercity travel within the UK. And I'll give you a little bit more context of that. So I'm not going to kill you by PowerPoint, but I'll take you through some images so you can get a sense of why Hitachi's invested nearly 17 million in battery technology for rail travel across the UK. This map that you can see in front of you now is very important for us as a business within Hitachi. In 2009, that was just the map of the UK. Right now, in 2025, that covers all of the routes that Hitachi intercity fleets now cover across the UK rail market. We operate over 300 train sets per day. So every day for me is tomorrow morning. Are all the trains in the right place, for example? So there's a significant amount of operational need and drive for passenger experience and performance. We have the most reliable fleet in the UK. Surprise, surprise, that is an electric train, and that was 3 years running. The Lumo fleet has been awarded the most reliable fleet in the UK market. We spent around £2.5 billion since 2015. So in a 10-year period, we spent a lot of money in the UK supply chain. Business around 3,000 people to manage this huge operational undertaking, which is 365 days per year. We also obviously maintain the majority of our rolling stock during the night. So we are 24/7 in terms of operations. So the task and the challenge around decarbonisation, we have around 750 to 1,000 engines roughly. We have more trains coming on board as well out of our manufacturing facility in County Durham. We have to look at decarbonisation as a business, and to have that many installed engines across our fleet, that's a massive challenge for us as a business. So what did we do next? Firstly, we'll touch on a little bit on heritage. So you can see the yellow train there in 2007. That's when I joined Hitachi Rail as a commissioning engineer. The first project we ever did, or I ever did working for the company as an engineer, was actually on a battery for a locomotive. We took the engine out of a locomotive and we put the biggest batteries you can ever imagine in its place. At that time, the system worked. However, it was too heavy, it was too expensive, and we just couldn't roll out the battery technology at that period. What Hitachi's done then globally since that, you can see a myriad of battery trains that have come out over a 20-year period of R&D. But as I've mentioned, we have this specific challenge within the UK market that we're driving to solve. So what we did, we chose specifically our Trans-Pennine fleet because that has a lot of hills on the Pennines. So we're getting worst case scenario in terms of the geography, which is very important from a battery operation fleet. It's a 5-car train set. We have 3 engines on a 5-car train set. We replaced 1 engine with 1 new battery, working in partnership with an organisation called Turntide Technologies, who were born out of Nissan. So that organisation has real in-depth knowledge of using Nissan Leaf technology. So the relationship, obviously, 2 major Japanese organisations, Hitachi and Nissan, we've created a hub around this from utilising the automotive R&D and expertise to see how we can drive that R&D and utilising our own expenditure of 17 million on the train itself to bring that technology from EVs, automotive, into the rail industry. So key partners, Angel Trains, Trans-Pennine, we fitted a 700 kilowatt battery set. It was absolutely enormous, as you can imagine, and it was an exciting piece of work. So our engineers have had the best time over the last sort of 12 months looking at this, making it work and taking it forward from an efficiency, but also from an innovation perspective. So fitting the battery itself, we then, going back to the map, what are the test results? So the hybrid train set, we ran 135 kilometres off the wires at full operation. That's at full rake, so that's normal operation. No impact to passengers, completely normal as if it was a fully diesel operation train set. So 135 kilometres is great. As you can all imagine, that's not quite enough to cover the entire network. But what you can see on the map there is the red lines are effectively electrified lines. What we have now established through our modelling based on that trial is all of the amber elements can now be effectively operated using battery trains without any overhead wires at all. So we can get distance covered in them specific areas. The blue elements which we're modelling now, there's two tough nuts to crack, which is the Great Western Network, which has very little electrification, but also the network out to Holyhead. If we have some battery and some diesel operation, we can mitigate that. So I think very important point when people discuss business case, we charge our customers tens of millions of pounds per year, over 50 million pounds per year on fuel costs. So there is an installed business case here in terms of what batteries do in respect of changing out for diesel engines, not just the benefits in terms of decarbonisation, which is the critical target. From my own business's perspective, you add that to air quality in stations, you add it to air quality in depots, you add it to the amount of time we spend at night moving trains to fuel lines to fill them. There is an efficiency piece that's being driven out of this trial which goes beyond just changing an engine to a battery. So the teams have done a fabulous job. We've concluded the trial now and converted the train back, and now we're looking at what next steps might look like. A little bit around for the technical, the techies in the crowd. Weight had to be the same, otherwise it would have been we'd had to re-homologate the train set, so braking distances, for example. So we literally mirrored within a tolerance what the battery size and weight could be in comparison to an engine to keep it exactly the same. The range, 700 kilowatt, we only had one engine fitted, so we believe we can get up to 150 kilowatt. We can get up to 150 kilometers on one train set with 3 batteries fitted. Acceleration is fundamentally the same in terms of operation, and we can operate seamlessly between battery, diesel, or overhead power. The passengers would not see any difference in terms of the operating usage of the train set. But the two biggest takeaways, I was asked to sort of point out what the surprises were from this trial and what we did. Charging time. Now, I have an EV car at home, and you can tell from my accent, I live in London, sometimes I need to go home to North, so I take my EV, and it's not always easy to charge it on the route back to Durham. It takes us about 30 minutes. It takes me 30 minutes to charge my car. We got to 50 minutes using the overhead power. There's no special charging system at all. We're using the pantograph to charge the battery, and it only took 50 minutes. Now, on some of the routes that we saw on the map, there is long-standing, the trains are sat in stations at the end of use, Penzance, Aberdeen, Inverness. These areas, they sit and have turnaround periods. So there is major opportunity in terms of charging operations that we can use around that 50 minutes. So that took us by surprise, because we were already talking with our Hitachi Energy colleagues around how do we work together on special rapid charging systems. So we can still do that, so we can go faster than the 50-minute, but the life of the battery is impacted. And the discharge time, just standing still. So if there's a train failure, the wires come down, the train stood still, it can sit there for 5 hours on auxiliary load just with that single battery. Where are we today? Back in 2012, we signed a contract and we thought diesel bi-mode was the way forward. 12 years later, we are now saying diesel is not the answer. And that technology within rail is going faster than we can keep up with because of the size and shape of our industry. Where are we today? We are ready. We can do tri-mode. So we can fit batteries now to our train sets, and we're looking at business cases and commercial solutions around how we make a tri-mode system. This trial is now active and it's ready to be implemented on the network. The ultimate aim, we can go to battery EMU now already. That says it's tomorrow, but the reality is we need the infrastructure to support that charging element across the full network. So next steps, as I've said, we're ready to deliver. advanced manufacturing opportunity. So we have an amazing manufacturing facility in the northeast of England. You can tell I'm very proud of that because of my accent. We can bring these trains back and we can take the engines off. It's installed base. It's upskilling our current teams within the manufacturing facility. So this is an important opportunity for us as a business. Continuous improvement in battery. We're aiming for 10 years. We could get to 12, we hope, on some routes. But what that means is the battery technology will keep getting better in that time period, is what we hope. Can it get lighter? Can it get more powerful? There's some great questions in there. And then really working very closely on what the industrial strategy is for decarbonisation and the wider benefits is next step. So I'll stop there and say thank you very much for your time.
Yeah, thanks, Jim. And great 20-year journey, and so thank you for sharing that with us. And great to hear the learnings you've taken from the automotive industry into the railway industry. Now, one industry I think, well, just replacing the diesel engine with a battery will not be quite as acceptable as aviation. So, Jane, over to you.
Thanks so much, Andy. Okay, so good afternoon, ladies and gentlemen. Wonderful to be here. So let me start with the elephant in the room question. Why do we need to decarbonise aviation? Well, hopefully this slide speaks for itself. Now, currently aviation represents, depending on who you speak to, I like around 4%. Some people talk about 2%, but I think it's a bit more than that of global emissions. But it is rising, and it's going in the wrong direction compared to most other sectors. Now, our industry body IATA says that demand for global air travel is forecast to double over the next 20 years. That's how much it's going to rise. So there's no question that we need to take urgent action. So what are we doing about it in the UK? Well, we're very fortunate here to have what we call the Sustainable Aviation Coalition. And that is a body that represents the UK's industry, aviation industry, as opposed to government. Now, this has responsibility for creating what we call our national roadmaps for net zero, how we're going to achieve net zero carbon by 2050. And I promise you this is the only graph that I'm going to show you in my presentation today. For the focus of today's discussion, I want you to look at the orange wedge and the dark blue wedge. They happen to be the largest two wedges in this map, which takes us from today. In fact, it starts in 2019 because you can see the COVID dip there, and it takes us up to 2015 and how we expect we're going to achieve net zero by 2050 in the UK. The orange wedge is sustainable aviation fuel, and the dark blue wedge represents future aircraft types, and that includes battery electric, hybrid electric, and hydrogen, and that's our second biggest wedge. So if we focus first on the orange wedge, the SAF wedge, SAF being sustainable aviation fuel, what is SAF? For those of you who've never heard of it, it is non-fossil derived fuel. It's available now. It's drop-in, so therefore it's blendable with existing jet A1, jet kerosene. It's currently certified to be blended up to 50%, and you've probably already flown on an aircraft that is partially powered by SAF and wouldn't have known about it. It's chemically identical to jet kerosene, and really it's the only long-term solution we have for long-haul flight. The challenges are that it comes with a significant green premium for its airline buyers, anywhere between 3 and 5 times more than jet kerosene. And there is just simply not enough of it being produced currently. But the advantages are that it needs relatively minimal new infrastructure compared to the other new technologies that I'm going to come on to in a minute. And here on this slide, we've got some examples of the feedstock types that can be used to convert into SAF. So top left-hand corner is fats, oils, and greases. That's being made today. Bottom left is municipal solid waste, so your black bin back waste that you put out the door every week. Top right is waste wood and agricultural residue, And bottom right is what we call power-to-liquid SAF, which is made from renewable energy, water, and a source of waste carbon like we have here, industrial waste gases. So SAF is happening now. It has great momentum. It's got a lot of government and industry support. And policies are actively being put in place in the UK to both mandate and incentivise production. And we're here today to talk about trials. So I'm going to just pick on a couple of relevant trials. The first here is the Virgin 100% SAF transatlantic flight that happened in November 2023. And this trial was actually sponsored by UK government. And it successfully demonstrated that engines can fly safely on 100% SAF, even though that's not certified right now. And the second trial I'm going to highlight is the Heathrow SAF incentive scheme. Now, the main issue with SAF, as I've mentioned, is that there's just not enough of it at the minute at the right price, and that's the key. And so it needs scaling globally. So this is a great example of a UK trial, the Heathrow SAF incentive scheme, which encourages airlines to uplift SAF by approximately halving the price gap between kerosene and its cleaner alternative, making it more commercially viable for its airline customers. Heathrow is one of the first airlines in the world to do this. It's quite innovative, and it sends a strong demand signal to producers to make more. Moving on to the blue wedge from the graph I showed you earlier, that's hydrogen, battery electric, and hybrid electric. So these are future solutions for realistically short and medium haul flights, not realistically long haul flight ever, we think at the minute. And these are, however, exciting new propulsion technologies, and they require aspirational new design concepts, as you can see from these images. These are a few examples. The top left is Zero Avio, which is a British-American hydrogen-electric aircraft developer developing hydrogen-fueled powertrain technology, aiming to compete with conventional engines in propeller aircraft to achieve zero-emission flight. Initially, they're going to start with relatively small 10 to 20-seater aircraft, and they intend to work up to 40 to 80-seater narrow-bodied aircraft. Bottom left is Airbus's Zero E program. This is an Airbus UK-based hydrogen-powered aircraft project, and it includes several concept hydrogen-powered aircraft designs. Top right is Heart Aerospace, and this is a Swedish manufacturer, and they're developing a 30-seat hybrid electric-powered regional airliner, and I'll explain a little bit later why I've included a Swedish manufacturer in my presentation. And bottom right is Vertical Aerospace, and they're a UK-based designer and builder of four-seater electrically powered vertical takeoff and landing aircraft, or eVTOL for short. We do like our acronyms, primarily to enhance urban air mobility. Now, ground infrastructure. Having all this new technology, aircraft is all very well, but no good unless you've got anywhere for them to take off and land. And that brings us to the question of how do you align technological readiness with infrastructure readiness? Now, primarily that means solving issues around fuel supply, storage, distribution, and safety. For hydrogen, that includes liquefaction machinery. Now, hydrogen is cryogenic, as you all know, has to be stored at minus 253 degrees C, and that means new hydrant systems and a substantial electrical power capacity. For electric, that means installation of charging infrastructure at scale. And the big problem for airports is timing, how and when to invest. Airport planning horizons are typically 10 to 15 years, and this infrastructure is not cheap and it's hugely risky. So if we move on to some hydrogen trials of note, it's worth noting at the outset that the UK, both government and industry, are broadly extremely supportive of hydrogen as a concept. Not so much of hybrid electric, and we'll come on to that. So there are there's plenty of funding availability for trials, and multiple trials that I could have chosen from to tell you about today, so I've had to summarize them a little bit. So here's some examples. The top left is Cranfield. Cranfield's formed a partnership with Heathrow, and they're doing some great trials on the Heathrow campus on turnaround procedures. Top right is the Aerospace Technology Institute Fly Zero program, which has done some fantastic project work on distribution challenges. Hydrogen Southwest, I had to mention that. Andy's quite involved in that, in Hydrogen Southwest, and that's a regionally focused coalition to develop the hydrogen economy in the Southwest. And, sorry, that's bottom left. And bottom right is Bristol Airport, who are really particularly active, particularly around the ground support equipment trial. So it's not just hydrogen for use in aircraft, but hydrogen also has a use in the equipment that turns around aircraft. And all these trials highlight that it's going to be highly complex, no surprise there, to incorporate hydrogen operations alongside conventional aircraft operations. It's going to require technological innovation, physical space, new people skills, new regulations around safety and emergency response, let's not forget, and a significant uplift in renewable energy requirements. Pertinent to mention at this point that Airbus have recently acknowledged this complexity by announcing they are pushing back entry into service date of their commercial scale zero-E hydrogen aircraft well into the 2040s. They originally pinned 2035 for the launch of their first hydrogen aircraft. And they are blaming lack of green hydrogen supply, regulatory frameworks, and the necessary infrastructure to support hydrogen-powered flight. And I guess we'll come back to that in the panel discussion. Moving quickly on to battery electric trials, drones and eVTOLs. So on the left here, Coventry have done a fantastic trial called their Air One trial to demonstrate the potential of advanced air mobility in a city centre environment and to drive public engagement. More of a challenge than you would think. On the right, vertical BIS to motion vertiport test bed trial, and that tested flight operations and ground infrastructure. Now, realistically, eVTOL operations will start from existing small aerodromes well before there's a network of new vertiports. So again, it brings into question the speed at which we can work out how to integrate advanced air mobility into existing operations. And if we turn now to hybrid electric trials, and I mentioned there are fewer of these to tell you about, but this, I think, is really the most significant. It's really fair to say there's been far less support here in the UK from both government and industry around electric aviation generally. Hydrogen has been the favoured fuel type. However, I mentioned Heart Aerospace, the Swedish manufacturer. And the reason for that is, excitingly, they have recently struck a deal with Loganair to explore the potential for hybrid electric aviation up in Scotland, which I think is extremely exciting. So just to conclude, this is certainly a constantly evolving and very exciting space. My main takeaways would be that UK government and industry may well need to have a little rethink to where efforts are focused going forward, perhaps not excluding things like hybrid electric at this relatively early stage in the aviation decarbonisation journey. And as Airbus have been at pains to point out following their delay announcement, let's hope their experiences will offer valuable insights for other sectors like road, rail and maritime undergoing their own decarbonisation trials, something I'm sure we will discuss more in a minute. Thank you so much.
Thanks, Jane. And yeah, big challenge, especially with the integration there of infrastructure, technology, and the alignment with the investment and timing. So all things to note. And SAF, I hadn't realised so much of an advantage of all our waste can convert. So that's a positive. But do we ever calculate that? So from one global transportation mode to another truly global one is around maritime and ports. So, Kirsty.
Yes, so last but certainly not least, I'll be covering maritime and ports and what we can learn from recent trials and demonstrations across the sector. First, though, I would just want to focus on the vision that we have for a future port ecosystem and how energy infrastructure plays a key part in achieving this vision. First of all, we've got renewable energy sources, so I'm considering both renewable energy generation at the port itself and also upgrades to the grid. Then we've also got net zero port operations, so looking at reducing our Scope 1 and Scope 2 emissions. And the really interesting and difficult characteristic that ports have is that several stakeholders are involved in this. So not only the port owner, but we have several operators, and there's a strong intermodal link with freight as the majority of our nation's trade comes through our ports. The third area is around shore power. So for those not familiar with this, it's where we're plugging vessels in and providing them with clean electricity as opposed to them using their main engines at berth and reducing emissions, therefore. And the last point is around alternative fuels for vessels. So in maritime, there's not one easy solution. There's not one drop-in fuel if we're going from traditional marine oils and diesel just because of the energy density gap. And that in itself presents quite a fascinating challenge across the industry. So those three latter points that I mentioned, I'll be diving into and looking at what trials are specific to each. So first of all, we've got clean energy provision to port assets themselves. And the trial that I wanted to highlight here was led by ABP at the port of Immingham. And that was the demonstration of a hydrogen terminal tractor back in 2023, supported by the Hydrogen Innovation Initiative. Really interestingly, on this project, the overall takeaway was that hydrogen is expensive, and this was compressed gaseous hydrogen for fuel cell operation, just to be specific. But there is a really interesting part of the report, which you can find online, which actually compares the hydrogen operation to electric. And the majority of the UK's ports are steaming ahead with electrification of port assets because it's easy, the technology is mature, and the main barrier typically is cost and energy capacity. So again here, we found that electrification of these sorts of assets would be easier than hydrogen, but require a lot more space, and hydrogen was actually much more comparable to current traditional fuels used in ports in terms of the space required. The other thing that surprised a lot of the operators was that there was no operational compromise for the hydrogen-powered assets. So we're looking at a refueling time of less than 4 minutes for this tractor. However, as mentioned, the total cost of ownership remains the most significant barrier when it comes to transitioning to hydrogen on the land side of our ports. We saw here that the assets themselves were around 3 times greater in cost than what we've been using for the past 50 years or so. And a recommendation that came out of this report was that we introduce a renewable transport fuel obligation for hydrogen production, and that would improve the commercial viability. So yes, it's a cost challenge at the moment, but looking ahead, we can learn from these sorts of trials to say, okay, in future, if we're to diversify between electrification and hydrogen, this is potentially how we do that. The second point that I'd mentioned was shore power. And I think we've had some great successes in recent years due to the government-funded zero-emission vessels and infrastructure programme, ZEVI for short, which you might hear bandied about sometimes in maritime. So I've highlighted one of the projects here, which was at the Port of Aberdeen, and we're a key partner of this actually. So if you want to discuss this further, please do grab myself and colleagues after this session. And through this programme, we're looking to introduce shore power at 7 berths across the Port of Aberdeen and reduce their vessel emissions by around 80%. In terms of learnings from the project so far and demonstrating shore power, one thing that became evident was that first movers, such as the Port of Aberdeen, need unique contractual agreements with the energy providers that perhaps weren't in place before. And there's a really interesting dynamic between the port itself, the vessels that will be using this electricity, and the electricity providers. However, projects such as this just emphasize that a place-based focus, a community focus is really favorable when it comes to looking at electricity requirements across the port city and potentially other benefits of bringing in the new shore power infrastructure, because there's significant amounts of cabling involved and being installed. You might ask, what comes next after this funding? Well, actually, that's one of the biggest challenges related to shore power adoption across the UK. Future investment sources are very insecure. And what we're finding with this project is that the government funding at the moment is brilliant, and we're getting to achieve things that we never thought possible without it. However, what comes next? Because the Port of Aberdeen, for example, are finding it's very expensive to continue on and use this electricity. How can we make it more attractive than continuing to use diesel engines is a challenge. But what we do know, and this is the last point on this slide, is that if we're moving to new fuels and shore power is installed, that will still be cheaper. So we're strongly incentivized for vessels at ports to plug in instead of continuing to use, say, for example, their methanol, hydrogen or ammonia engines, because this electricity will still be cheaper. And thirdly, the point that I mentioned earlier, looking to supply new fuels to vessels. So looking at low emission options, looking at zero emission options. The one demonstration project that I've highlighted here is the High Fived project, which is really innovative, involves two SMEs that we work very closely with, actually. Unitrove, who are providing their multi-fuel station for ports. That's the image on the left. And on the right is Aqua Ocean, who are providing their liquid hydrogen autonomous vessel. As with any sort of project that's really pushing the boundaries of innovation, they've came up against quite a lot of regulatory challenges, and especially because it's liquid hydrogen as opposed to fuel cell usage. One thing that is evident, not just for small short-range vessels such as the one highlighted here, but looking across long-range, say for example transatlantic vessel travel, a multi-fuel future is certain for maritime, and I think that dynamic really sets it apart potentially from other sectors. A lot of this will be based on what fuel is available, where you are in the UK, and where you need to go in terms of the vessels that you're serving. And that in itself brings upon quite a unique infrastructure challenge. When it comes to transitioning vessels to alternative fuels, we are still in preliminary stages because the technology is still evolving. And that does mean that we're constrained by the energy supply and costs because the supply chain is still in its early stages of development. And therefore, we're seeing that the industry is actually transitioning to transitional fuels. And by that, I mean we're not going the full step to zero emission fuels. We're not going the full way to ultra low emission fuels. We're going almost like halfway there in terms of lower emissions than today and dual fuel options. So it means that if that's the focus over the next 10 years, we might be shifting our infrastructure towards that and need to shift again to the ultra low emission and zero emission options in future. One positive that I wanted to leave on this perspective, though, is that innovations such as this are really driving new regulations, and developing that together between industry and government is really interesting. And also with the introduction of the UK emissions trading scheme to maritime, that's seen as a real positive in terms of driving change. So ultimately, when we consider the journey ahead for maritime, there are lots of positives that we can take from trials and demonstrations to date. But the challenge ahead can seem daunting, and that's why I wanted to put this graph on the screen here. This came from the DNV last year, and it's their projection of the maritime fuel mix looking from now until 2050. As you can see, oil is projected to play a strong part for many years to come, and the fuel mix is seen as quite diverse. This is, of course, just a projection, so it'll be interesting to see how this changes over time. But there's 3 points that I really wanted to emphasize in terms of how we get from the left to the right of this graph. Number 1, Definitely increased renewable energy generation, which can be a challenge given space constraints within ports. Number 2 is looking end to end at the UK supply chain, collaborating between off-takers and producers to make sure that we're meeting new demand. And the third is a holistic place-based approach to make sure that we're maximizing community benefits where possible. And I, for one, I'm very motivated to accelerate us on that journey from the left to the right. Thank you.
Thank you, the panel. Right, we've got some time for some Q&A, so if you've got any questions, put your hand up, and there's a mic going around the room. So, but whilst you're thinking of questions, one question for the panel. So great conversation, great innovations. So how do we break down the silos and do that cross-sector learning? So we heard about how the rail sector learned from the automotive, but how does the automotive or HGVs then learn from rail? Or how does, looking at the graphs there, very similar in terms of maritime and aviation. How do we learn there and from the trials and what we're doing, so we don't replicate or duplicate what other sectors are doing, and so we move the dial forward rather than just repeat what each sector's doing? I'm going to start, Michael, at the end.
Well, I think one area, actually, speaking to the person on your left, my right, is that I think there's a big opportunity for starting with those organisations that already span both. One of the issues with the investment, so much of this is related to this tension between the upfront capital required and the ongoing OPEX needed to keep it going. And you often find that, the TCO is killed by the lack of upfront capital. And I think like organisations where they have a combination of good WACC, weighted average cost of capital, and investments that span both. So much of this boils down to there being an investment committee that's capable of dealing with it. And I actually think that organisations such as Hitachi, where they're used to taking investments across the sectors, are the ones that could be the beacons that start to show how integration is possible. So, go where it's easiest. The decision making is often the barrier. Partner with those entities that are used to taking cross-sectoral decisions.
I would just add that the government, I think, has a very significant role to play here, and they are the central body by definition. In aviation, we've got something called the Jet Zero Task Force, was council, and under the Tory government is now the task force, relaunched happily, and it is a government, industry, and academia tripartite collaborative body, and I think that those organisations are very important. I don't know whether the same exists in maritime, road and rail, but then those learnings from aviation in theory get taken back into government and can be disseminated more easily from a central perspective. That's the theory. I'm not sure it happens in practice.
Just to add to that, I think that is also one of the roles of the Catapult network.
Yes,
so yes, we are connected places, but we also have other catapults across the UK, and because we sit between government, academia, industry, we definitely strive towards being the connector. But looking away from government and industry and innovators, I think it's really important to continue understanding where innovative technologies lie and where they've been successful in, say, rail and road and aviation. And in maritime, we're always looking at the programs we run and saying, can we transfer that technology that's been successful across? And continuing to do that will be quite important.
Okay, thank you. I think just to add, from my perspective, we often talk about net zero decarbonisation 2030, 2045, 2050 in different countries across the world. And I think what we actually need to do is, what's the interim steps? How do we do it in 3 years? What's 3 years? What's 5 years? Because the trials that we've seen today are incredibly positive in terms of not only investment, but in the catapults industry. Universities have got a massive role to play in this as well. But how do we bring that together? And I think you have to look at maybe some simpler targets. Now, targets aren't the be-all and end-all. I don't think they have to be achieved necessarily, but they have to guide all of them different industries or counterparts in terms of driving towards a successful outcome. So transport, we're blessed at the minute because we have a significant role in sustainability, and the projects that we're all working on are really exciting. It's great to be part of that. That's exciting stuff. But I do think there's a transport advisory board element in this. So not government. There has to be an element which is more advisory around the sustainable outcomes that we're looking at local government or at government level. Because from an Hitachi perspective, we love your problems. That's exactly what we are here to deliver and solve. So I'd like to see some interim steps and a little more coordination around simple deliverables that all of us can bite on.
And do you think, I think that's a great idea, Jim, and do you think that then will help build on and scale some of the trials that we've seen in your presentations to actually become then, take it from a trial to something full implementation across the sectors?
I think, we don't want to hog the answers, but fail fast, fail big. Failing big is not necessarily an issue. Failing fast is not necessarily an issue, because that's all learning that we can apply collectively because we're all trying to solve the same problem from a different perspective in different areas. So fail fast, fail big, and don't worry about it if it doesn't work, because we'll take something and do something else.
Okay, excellent. So, any questions? Oh, we've got a question on the front there.
Andy, sorry, it's me again.
That's all right.
Again, lots of questions I could ask, but on the aviation one, I thought it was really interesting, your slide showing the sort of projection out. You mentioned a couple of the slices, but one you didn't mention was I noticed there was decreases in demand driven by the costs of decarbonisation. And so, to be slightly provocative, would it not make sense to set a carbon budget for aviation, which is a steadily reducing budget over time, and simply allow for the fact that the constraints on supply of SAF will drive price up, and if the price goes too high, that'll drive demand down, and the market will find a level for you to hit that budget going forward, and hopefully bring forward investment in more SAF capacity or other forms of aviation as a result.
Yeah, I think you've hit a very important point. I mean, there is no question that the desire, or the demand rather, from us as customers to fly more sustainably, because we want to have our cake and eat it. Let's face it, we all want to carry on flying and going on our holidays and going to see friends and family, but we all want to fly sustainably. The airlines are going to want to buy more of it and are doing so, and that's going to force ticket prices up. So there's going to be a natural suppression in demand. And I think the carbon budget is going to be imposed upon us externally, and we've seen the CCC report only published last week, and they are seeking to place more emphasis on SAF, which is great, but they're also seeking to impose more demand management, which of course the industry doesn't like very much. But I think personally that's a little bit of an inevitability. If we're going to have any chance at all of achieving net zero by 2050.
I think to add to that, actually, from a flying point of view, it's not just about us as passengers flying, it's also about freight. So, historically, it would be you order something and it comes a week later, especially if it comes for a further afield, but now it's all next day delivery, so it all comes in. East Midlands Airport, got record numbers of freight flights coming in, so yeah, it's. I think all of us as a human species have to look at actually our behaviour, and that drives consequences in the how things travel and imported into this country. Any further questions? There was another question. There was a few hands up over here. No. Yep. Okay. I'll whilst you think of another question. So in terms of the trials, what are they telling us on whether decarbonisation pathways and targets across each mode are achievable? There's some good data from Hitachi, but are those targets achievable in maritime, aviation and roads? No.
Well, I think the Airbus decision has proved that, and there's been a huge realisation in the sector that they've perhaps been a little ambitious, particularly in hydrogen, around that 2035 target, and there's been this big rowing back. And I think what that shines the light on, and I think we all mentioned it in various guises, is the need to align across the entire ecosystem. So Airbus pointed to infrastructure preparedness, regulatory preparedness, and availability of green hydrogen. Yet they went for a target of 2035 without really sense checking before they did so that was achievable. And now to their credit, they have in 2025 rode back on that and placed a huge amount more emphasis on those three buckets of the wedges of the ecosystem that they need to work much more collaboratively with in order to achieve the pushed back target. They're very at pains to say this is not tools down, and they're very at pains to encourage that particularly the infrastructure providers and those that are going to design the regulatory framework not to put their tools down either. This is not, you don't need to worry about this for the time being. This is, you need to get on with this, and you need to do it as fast as you were, but we don't think you're going to make the original target. So I think there's an element of realism coming in to the space now.
Yeah, I think certainly in maritime it's highlighted that there are many areas of uncertainty that remain, and really interestingly, what we hear for the industry is that they don't want to put all of their eggs in the basket of one fuel and have it be that that's more expensive than the other. And I think this is where the intermodal element is really interesting, because there's a concern that, for example, aviation will take all of the biofuel and there'll be not enough left for maritime. Or is it that HGVs and aviation will take a lot of the hydrogen? So that's where the place-based focus is really key, because actually if we can look more holistically and say, let's divert that X to aviation, Y to maritime, at least for this city and wider place, we'll look at it and be able to understand, make more accurate predictions. Michael?
So one negative thing, one positive thing. It's not just about thinking about the system within transport, it's thinking about the system overall. So hydrogen, just existing uses of hydrogen, turning that green. Right, 55% of the world's hydrogen right now is used for ammonia, which is fertilizer. Right, 25% refining fuels, 10% hydrogenation, on margarine, and 10% is on chemicals. To turn that green, it would require 143% of the total installed renewable generation capacity in the world, just to the existing uses of hydrogen green. Right, so actually, it's an even bigger system. I think the one thing that I would say in terms of positive is that the projections on technology development, I think in most instances, particularly for electrification, are going a hell of a lot quicker than anybody envisaged, right? More and more is becoming possible. Hydrogen does still struggle, but what I would say, with technological optimism, I think it's definitely worth driving and fighting for. So, particularly on battery prices, if you look at the IEA projections of battery production, every single year, I think for the last 10 years, they've underestimated what has actually happened in terms of genuine real world supply. So if you do focus on a technology, and then it can go. And I think the challenge for government is that it tries to be very neutral. And I think it raises the interesting question is, do we actually have to place some bets, and actually push certain solutions for certain environments? So yeah, tough, but I think there are at least some reasons for optimism.
Right, any further questions in the audience? Okay. We'll actually continue to ponder. So in terms of moving the dial, how important is technical innovations set aside alongside other levers which you mentioned there, so in terms of governance, regulation, or interactive investment?
If I can, I think just to touch on the last point as well, the railway can be decarbonised in time. It can be. We can fully electrify the railway, and we could have done that maybe 20 or 30 years ago, frankly. You can do, but what we've learned through the trial is that decarb in rail is very, very possible and achievable, even on longer distances, utilising discontinuous electrification. So there's a hybrid step between the two. So very positive from that point of view. Rail is the greenest mode of transport, and the more people that use rail allows, we are becoming, we're moving towards an energy efficiency piece. So I think the emphasis, what we've learned is, yes, we can decarbonise, but we're going to need more energy. So energy efficiency is the next step. So actually, Hitachi is moving more to the idea of how do we become more energy efficient. So the movement of people, we can decarbonise in rail, we're very fortunate, but we're dead interested about what the panel are thinking about as well in their specific areas, to see if we can learn something and apply that, because we can do it, but we need to manage our energy better. We need to be more efficient on the movement of people, and we need to look at, to Michael's point, we make some bets, but actually what's common sense? So if we can get a fully electrified railway, that's very difficult and very expensive, but if we can demonstrate there's a business case benefit to that in the longer term, and we're moving people using less energy, should there be more funding then for the other modes of transport? Maybe. So it's that holistic view of actually what works and where common sense is applied to drive the benefit of decarbonisation, energy management into the future. Because as a country, the UK is going to have a challenge moving forward like everybody else. So I think there's the criticality around, yes, we can decarbonise things, the technologies are there, they cost a lot of money, or they're going to mean more energy, and we need to focus on parallel things at the same time and make common sense bets. So hydrogen for us in rail is probably freight, because they have more movement, whereas on passenger rolling stock we can either battery or we can use electrification. So I think there's a common sense bets piece here, and shorter targets and check-ins. And for big companies that they missed the timing, I don't think we should bash them on the head for that. Actually, I think the question we should be asking is, yeah, but why? What did you learn? What went wrong? What are the things that stopped you from achieving that target? And can we apply some thought to how we resolve them things in order to speed up your ultimate objective? They're the questions I think we should be asking.
Well, I'm going to give the same answer that I did to a question earlier on, but for a different reason. It's government. All roads lead to government in aviation. And the biggest wedge in that graph that I showed you was SAF. SAF is going to by far be the biggest contributor to aviation decarbonisation. And I mentioned in my presentation that one of the big challenges is we haven't got enough of it, and that's because there's not enough of it's being made, and that's because the producers aren't making enough of it, and that is because the investors regard it as too risky, and that is because government are not putting in place the right policies. Now, I say that actually in the UK, our UK government is, in fact, relatively far ahead in global terms in designing the appropriate policies. We've got a mandate which has started in January this year that we are aiming towards 10% by 2030, and we're making good progress towards what they term a revenue certainty mechanism, which will address that price volatility challenge, so that it will give the investors that confidence that they need to invest in the production facilities that we need to be producing more of this stuff. So it all leads back to policy, in my view.
Okay, I'm just conscious of time. So first of all, just thank you to the panelists for a great session today. You've heard it here first, that all the railways will be decarbonised on time. and helping to bring along the other transportation modes. Thank you for your session today. I'm going to finish 5 minutes early because in the main keynote speech area in the main hall, there is a keynote on dedicated autonomous pods that are going to be installed between the new high-speed 2 interchange and Birmingham Airport. So I don't want you to miss that technology. So as we always do, just give a round of applause to the panelists. So thank you. Thank you.